Hi and welcome to this introduction to the Spring Framework. These series of tutorials are going to cover the Spring Framework and we'll learn how to use the Spring Framework in our Java applications. Now, what is a Spring Framework? It's actually a lot of things put into one, but the thing that Spring is really popular for is dependency injection. We'll learn what dependency injection is in this tutorial, and that'll form a good introduction to Spring. And as we go on in the further tutorials, we'll look at some of the other capabilities of Spring and the other roles that Spring performs in our application. Now, what is dependency injection? This is sometimes called as dependency inversion, and the definition is it's a way in which you decouple the conventional dependency relationships between objects. Say you have two objects that are related to each other, one is dependent on the other. The idea is to decouple this dependency so that they are not tied to each other. I'll just take an example to explain what this concept means. Now, let's say I have a drawing application and I have code that draws different shapes, a triangle, a circle, and a square, and I'm using that code in order to draw certain shapes on the screen. Now I have a circle object, say, and the circle object has a draw method, and I have a triangle object, and the triangle object has a draw method. Now I can use these objects in order to draw a circle or a triangle on the screen. So let's say I have an application class. I can instantiate a circle object inside this class and I can draw a circle. I can instantiate a triangle object inside the class and I can draw a triangle. So a code would be something like this. I would say triangle, my triangle equals new triangle. So I'm instantiating a triangle object here and I'm calling the draw method of that triangle object. Similarly, I'm instantiating a circle object here and I'm calling the draw method of the circle object. Now let's say I don't want my application class to be tied specifically to these objects. I want to use polymorphism. Now how do I do polymorphism here? The whole idea of doing polymorphism is having some kind of an interface class or a parent class, and I use the parent class in order to execute the methods of the class, and then at runtime I supply different children of the parent class and the methods of the child gets executed instead. Let me clarify that by showing you how I would modify the piece of code in order to implement polymorphism. So let's say I have this circle object and I have this triangle object. Both have a similar draw method. Now what I'll do is I will have a shape interface or a shape parent class that has a draw method, and I will make both the circle and the triangle object inherit from this shape interface or the shape parent class. Now what's going to happen is the circle object is going to override the draw method of the shape, and the triangle object is going to override the draw method of the shape. Now this draw method of the circle will contain the code to draw the circle, and this draw method of the triangle will contain the code to draw the triangle. Now if I have to use polymorphism in my application class, what I would do is in my application class I would write code like this. Instead of initiating a triangle, what I would do is I would say shape equals new triangle. Instead of saying triangle equals new triangle, I'm going to put this inside a shape object. Similarly, I'm going to instantiate a circle and put it inside a shape object. Now what I'm going to do is I'm going to call the shape.draw. Now if shape has a triangle, it's going to call this draw, and if the shape has a circle object, it's going to call this draw. So this is actually polymorphism in action. We are doing something that uses polymorphism concepts. Instead of calling the method of the object itself, I have a handle to this parent object, and I'm going to call the draw of the parent object. Now this parent object could be an abstract class, it could be an interface. The whole idea is that I do not know which object I have when I'm calling this particular shape.draw. Okay, so this is a simple implementation of polymorphism. Actually, it's not really polymorphism because see, what we are doing here is we are still tying the code to a triangle or a circle. I'm still instantiating a circle object inside the application class if required, or a triangle object inside an application class if required. So the application class always knows whether it's a triangle or a circle. So there's really no point in using a shape. You're not getting any benefit out of it. It's still hard-coded to use either a triangle or a circle. So we'll take this a step further. So what we'll do next is, instead of having the code hard-coded, what I'm going to do is I'm going to write a method. Okay, I'm going to have this method called myDrawMethod, and this is going to take shape as a parameter. Now this shape could be anything. It could be a circle or it could be a triangle. Now this method does not know. All that this method does is it just calls the shape.draw. Now depending on what object you pass to this myDrawMethod, if you pass a circle, this myDrawMethod is going to draw a circle because it's going to call this method. Now if you pass a triangle, the myDrawMethod is going to draw a triangle because it's going to call this method. But essentially what we're doing here is the myDrawMethod does not worry about what shape it is. It knows that whatever object is being passed is a shape, and it will have a draw method. How it's actually implemented in a circle or a triangle is not the business of this method. It just calls the draw method, and depending on what object is passed, it draws a circle or a triangle. So this is fine. We have actually removed the dependency of the circle or the triangle from this method. But still note that somebody has to pass this object to the myDrawMethod, right? There's somewhere an object is created, a shape object is created, be it a circle or a triangle. Somewhere that shape object is created, and this myDrawMethod is called. So there has to be another piece of code in this class which has the initialization. Say somebody has to do this, shape equals new triangle. Somewhere else in the class this has to happen, and then we need to call the myDrawMethod by passing this shape. So we are still tied to this new triangle, right? We are still not free from it. Somewhere else in the class we need to have this new instantiation, and we still know what's going to happen. So no matter how many ever times you run this class, it's still going to draw a triangle because we have this new triangle in place. Now if you have to change this, you will have to modify the class. Of course you don't have to change the method because this you have insulated, right? We do not have to change this depending on whether you want to draw a circle or a triangle. We have taken that dependency out of this part, but we have added it in this part. So if you have to change this to a circle, I'll have to change this line of code, and the same class will have to be modified. Okay, so now we'll take it a step further. What we'll do is this dependency, we'll take it outside the class. Okay, and the class will not know what shape it's drawing. The class will just have a shape, and then we will expect some other class to provide the shape for us. So right now what's happening is, in our application class we have this triangle object, right? Because we have a new triangle inside this application object. So what we need to do is we need to have a shape object here instead of this triangle object, and we will ask somebody else. We don't know who that person is yet, but we'll ask somebody else, some other class, some other object, to add this triangle or shape or circle into this application class object. So this is how it's going to work. What I'm going to do is I'm going to have a drawing class. Okay, this drawing class will have a class member variable called shape. It's not going to be a member variable triangle. It's not going to be a member variable of circle. It's going to be a member variable of type shape. Now assume that I have a code like this. I have a class drawing. I have a private shape object. Now what I'll do is I'll define a setter here. I'll define a public setter, set shape, and I will take a shape object and I will set it into this shape. Now this can accept a circle, this can accept a triangle, tomorrow it can accept a pentagon, hexagon. As long as it's a shape, it'll accept this object. And whatever object, whatever shape object is passed, it's going to set it inside this class. It's going to set it as a member variable. And then I have a draw shape method, which just draws, it just calls a draw method of this shape, whichever has been set. Note that this does not do an initialization. You don't see a new shape here, you don't see a new triangle or a new circle. Okay, the drawing class is going to assume that somebody is going to instantiate that and provide that object to this class. Okay, so now what's going to happen is we are now totally removed the dependency from a triangle or a shape. Now if you want to draw a triangle, you don't have to modify the drawing class. This is going to remain the same. All you need to do is pass a triangle to the setter. You have a drawing.set shape. If you pass a triangle to this setter and then do a drawing.draw shape, it's going to draw a triangle. If you pass a circle object to the setter, you say drawing.set shape and you pass a circle object, and then you do a drawing.draw shape, it's going to draw a circle. So what's going to happen is in a different class, you will be doing this. You will be having a triangle, my triangle equals new triangle. I will instantiate the triangle, and then I will have an object of this drawing class. I will do a set shape and I will pass the triangle. Now it's a triangle, it can be any shape, it doesn't matter. And then I will do a drawing.draw shape, and then the drawing class, it doesn't know what shape it has and it doesn't really care. It just calls the draw shape method, and it's going to call the draw method of the corresponding shape, be it a triangle or a circle. Okay, so now the advantage here is that in our drawing class, instead of having an instance of a specific shape as a triangle or a circle, instead of having an instance of a specific shape, it has an instance of the parent shape object. So this can be anything. Now what's going to happen is I will have a different class which has a triangle, and then this class is going to pass the triangle to this drawing class, and then the drawing class is going to have a triangle. If this class passes a circle to this drawing class is going to have a circle. And then again, as I said, it's open for new objects to be instantiated as long as the object is a shape. So you might draw a new shape, you might create a new shape object which has 100 sides. As long as it's a shape, you can pass that object to this drawing class, and all that the drawing class does is it calls the draw of that shape. The whole idea is that you don't have to modify this drawing class. You just have to pass the corresponding object in a shape, and then the drawing class is going to draw it. But now you might ask the question again, this will have to be modified, right? This different class has to be modified. You need to set a circle for having a circle to be drawn. We need to set a triangle for having a triangle to be drawn. So of course, something has to be changed in order for a program to change. The whole idea is that you are separating the whole dependency out of a class. The drawing class doesn't really know what it's dependent on. It doesn't really know what it's drawing. And the advantage of this is that if what it has to draw changes, you don't have to modify the drawing class because it doesn't really know in the first place. It just draws a shape. So you can make the drawing class draw all kinds of shapes without even modifying, without even changing a line of code of the drawing class. And the reason it's happening is because the dependency of the drawing class to a shape object is not owned by the drawing class. The drawing class does not own the relationship. The drawing class just has a shape. It does not own the relationship of the actual shape that it's drawing. It doesn't own a circle, it doesn't own a triangle, it just owns a shape. And now the dependency that the drawing class has, dependency to the triangle, is actually injected to the drawing class by something else. It's injected by a completely different class. So this is the principle of dependency injection. Here you can inject a dependency of the drawing class to a triangle. You can later inject a dependency of the drawing class to a circle. So the dependency is not hard-coded in the class, it's actually injected by an entity outside the class. So this is the whole concept of dependency injection, and this is something that Spring makes it very easy to code. Actually, what happens is that this different class that we said, we still need to write in this scenario, we need to write this different class that instantiates a new triangle and then injects the dependency to the drawing class. Even this is taken care of by Spring. You just tell Spring saying, hey, I have this object, now inject this dependency to this object. So you don't have to write this class, you just call the draw shape and then you configure Spring to inject the right dependencies to the right objects, and Spring takes care of that. So this is a very high level overview of dependency injection. I hope the concepts are clear. In the next tutorial onwards, we will use Spring to actually implement this dependency injection, and whatever questions you have, I hope it'll get clearer down the line.